I'd like to review the idea of polynomial long division because for some of our integrals, we're going to have rational functions as the integrand. Remember, a rational function looks like a polynomial over a polynomial. I've just named these n and d for numerator and denominator, but those two guys are both polynomials. And so recall from algebra that in some instances we can reduce polynomials, right? And that is specifically if this is what we call improper. If the degree of that polynomial on top is equal to or greater than the degree on bottom, that rational function is considered improper. And that means we could do polynomial long division to reduce it down. So just a reminder, if that degree on top is greater than or equal to the degree on bottom, then we say that rational expression r of x is improper. In other words, we could do some division. So let's refresh ourselves on how we do polynomial long division. So for example, say we had this 2x to the 7th plus 3x to the 5th minus 9x cubed plus 4x squared. Going to need a bigger fraction. Minus x plus 1 over x squared plus 3. So it's a rational function. It's a rational expression here of polynomial over polynomial. That degree on top is greater than or equal to that degree on bottom, a 7th degree over a 2nd degree. So we should be able to do division and reduce that down. So we write it out just like we would be doing division on numbers in our long division format here. X squared plus 3. And the degrees of the terms end up being like the place values for numbers. So remember, anytime we skip a degree in here, I'm going to put in a 0 as a placeholder. So when I do my division, there's a place for everything there. So 2x to the 7th plus no 6th degree terms plus 3x to the 5th. No 4th degree terms, minus 9x cubed, plus 4x squared, minus x plus 1. OK, so I want to divide this into here. I just focus on these lead terms to start. So I'm trying to divide x squared into 2x to the 7th. So that's just 2x to the 5th. So I'm going to line stuff up by degree. So 2x to the 5th. Now remember from just number division, now I want to multiply these and find my remainder. So multiplying, that's 2x to the 7th. There's actually no 6th degree term here when I multiply, so I'll just put in a placeholder. And then plus 6x to the 5th. And then subtract. And just be careful. Unlike numbers, when you do division, some of this stuff's going to come up with negatives. 3 minus 6 is a negative 3x to the 5th. So subtract, there's nothing, nothing, and a negative 3x to the 5th. I always put the parentheses on here just to remind me there's a minus all the way through there. to keep track of. All right, now I bring down my, notice that we needed 3 terms at a time here because this guy skips a degree. So I'm going to bring down the next 2 terms to get a total of 3. So now I need to divide this lead term x squared into that lead term there. So the lead term's 3x to the 5th. I'm trying to divide in x squared, negative 3x cubed. Again, I could put in a 0 placeholder, but usually up top, since I'm just writing the numbers, I'll just skip that space. So minus 3x cubed. Multiply negative 3x to the 5th minus, again, there's not going to be any x to the 4ths, minus 9x cubed. And that actually goes in there exactly, because remember, you're subtracting, so that's a negative 9 minus a minus 9. That's 0, 0, 0. Well, we've been needing 3 terms, and we really have no terms right now, so I'm going to bring down everything, the remaining 3 terms I have. Now, when do you stop? Well, remember, let's think about what it means to be improper. The degree on top, if it's greater than or equal to the bottom, it's improper. So as long as the stuff we have left over, we're trying to divide that into this. As long as this polynomial is of degree 2 or greater, we can keep dividing. So once this is of lesser degree than this, then we know we're done, and that's our leftover. So we can still keep going. I'm trying to get x squared to go into 4x squared. That goes in 4 times. And no x's, plus 12. Subtract. Negative x minus nothing is negative x. 1 minus 12 is negative 11. So what's our result here? This is of lesser degree, so we're done. Now this divided by that, this thing here divided by that quadratic is proper. So we're just going to leave that as our remainder. So this went into here that many times with this left over. So our result is 2x to the 5th minus 3x cubed plus 4 plus our leftover. We're sitting here wanting to divide that into that, but we can't, so that gets left over. So why are we interested in knowing that this could be rewritten as this? Well, think about integration. We have no idea how to integrate that. It's a big polynomial over a polynomial. But think about what we're left with here. This is just power rule stuff. We know how to integrate all those terms. And now we're still left with a rational expression, but it's much simpler. And we have some ways we can deal with that. This thing, as is, we wouldn't know how to get the antiderivative up. So the idea is to reduce these impropers to a proper to get something simpler. And so we'll be doing this long division as a method of reducing rational expressions. So whenever you see an integral involving a rational expression, the first thing you should ask yourself is it even proper? If not, you're probably going to want to do long division, unless there's something obvious you could do with it without bothering with the long division.